Hi, everybody. Super pleasured and honored to be here. So this is a kind of an awkward situation for a workshop. So usually I teach workshops with 10 or 20 students, and this is like a huge room. So this is going to be a little bit more like a master class. What I thought I would do is show some examples, talk about as an artist, how I work, some of the things I'm really passionate about, and then introduce openFrameworks, which is a tool that I use, and then show some examples and kind of code a little bit and talk through what I'm doing. I would love you to feel free at any point to ask questions. So, if there's something that I say that you would like me to go into more detail on, or more kind of technical information, or just any questions that you have, please feel free to raise your hand and jump in, or write them down, ask me after. But I'm really curious. I'm curious to learn more about you and learn what you're up to. I'm going to talk about myself, but actually really want to know about you. And this is my first time in Istanbul, my first time in Turkey, so I'm super happy to be here. So a quick introduction. I talked about it yesterday. My background is in fine arts. I studied painting and printmaking. And when I came to use the computer, I got really frustrated because the drawing tools that you have on the computer are quite limited. So if you use Photoshop or Illustrator or any of these kinds of products, they're simulating what it feels like to draw with a brush or to draw with a pencil. But it's not the same as actually drawing with a pencil or with a brush on paper. And so one of the things that I've been trying to do as an artist is explore drawing on the computer. What does it mean if we're using software? How can we use the computer in a way to manipulate drawing, to make drawings come to life, or kind of add something to the act of drawing? Because I think drawing's really kind of fundamental to what it means to be human. So one of the first things that I made when I started writing code was this very simple drawing tool where you draw a line, and the line uncurls itself. So the idea is that as you draw a line, based on the curvature, the line kind of wants to unbend. So if you draw a straight line, it doesn't have any energy. But if you draw a line with a curve, the line kind of wants to uncurl itself. And so through the act of drawing, you're programming the motion, right? If you draw a straight line, there's no energy. If you draw a line with a lot of loops, then you can kind of control how it moves. And this is a kind of what-if question. What would happen if you made a drawing and you said, how could the line uncurl itself? And a lot of times as an artist, I find myself asking this kind of what-if question and then writing software to try to answer that what-if question. I'm going to show you some other drawing projects to kind of like keep going with this theme. I did a performance many years ago where I would be on stage painting, and the audience could see what I was painting behind me. And because I love painting, I love using a brush and working with ink. And this performance is inspired by Thomas Edison and John Stuart Blackton. So this is a film from 1905 called The Enchanted Drawing. And here you can see a drawing sort of coming to life off of a piece of paper. So if somebody draws something and then grabs the drawing, and the drawing comes off of the piece of paper. And this is the Portuguese artist Helena Almeida. And Helena Almeida would paint on top of black and white photographs. So here she paints a blue dot, she picks it up, she eats it, and she cries blue tears. And there's something I really love about this idea of paint as something physical, as something you could touch. So I made a performance where I was on stage painting, and then I could touch the painting, and the painting would kind of come to life.
続いてご紹介するのはザッカリーさんの作品ドローン。ザッカリーさん、白い紙に何やら書いていますが、あらら、動き始めましたよ。
I don't know what she's saying. So I hope it's good. So I'm on stage painting. I have a camera pointed at the piece of paper, and it's a little bit like a magic trick where I'm kind of, I'm actually really painting, but that I can touch the paint and it moves and does kind of, interesting things. It makes sound. And there's something that I noticed when I was doing this performance. So we were touring in Japan, and after the performance, everybody would want to come up and try it and understand what it was about. And I decided to make an installation version for other people to try. So one of the things that I find as an artist is sometimes you're doing a performance where you are taking people on a journey, or you can also build installations where you invite participants to become performers. So I made an installation where people can come and paint ink and interact with the ink and the things that they've touched. I can show you just a short clip of that. So you can come and paint yourself and then touch the painting. And there's something that I noticed when I watch people interact with this project I got really obsessed with. I call it the open mouth phenomenon. So I want you to pay attention to this kid. This is in a festival for children in Amsterdam called Cinekid. So this is number 1, number 2, number 3, number 4. So this is what I'm interested in as an artist, is this kind of open mouth, right? Creating these moments of open mouth, because I would make the argument that an open mouth is a pathway to reach somebody's heart. And I should keep talking about drawing projects, then I'll talk a bit about open frameworks, and I'll show some drawing examples. This is a project that I worked on a while ago called the iWriter. It's a collaboration between myself, Chris Zagru, and Theo Watson, and the three of us work on open frameworks, which is this toolkit that I'll talk about. And I'm going to show one of Chris's projects. Really amazing artists. And the three of us collaborated with Evan Roth and James Potterly from Graffiti Research Lab. And this team of 5, we had a 6th artist that we worked with called Tempt. Tempt is a graffiti artist from LA, an old school graffiti artist. From the 90s, he was doing really interesting stuff around Southern California. And over a decade ago, he fell over and he was diagnosed with a disease called ALS. In America, we call it Lou Gehrig's disease, because there was a famous athlete named Lou Gehrig, and it's a disease that attacks your muscles. So he's completely paralyzed. And we went out to LA to meet him, and just to show him the kind of work that we do, this kind of media art, like talk about this kind of practice, and just show him the work. And we got to know him and his family and his caregivers. And he's completely paralyzed, so he can't move his body, but he can move his eyes. And he had a commercial eye tracking system. So this is a computer that's looking at his eye movement, and he's saying, dude, my hardware is ghetto. But he could also be saying, dude, my hardware is expensive, because this equipment costs $5,000 to $10,000. And there was a long period of time where he didn't have this machine. And when you don't have a machine, you have there's somebody with a piece of paper, just an interpreter, that points at letters of the alphabet. And then when they get to the right letter, you can kind of signal with your eye movement. And so we went out there sort of not knowing what to expect and just trying to figure out what we could do. And this machine, he could type messages, but he couldn't draw, he couldn't do what he loved, which is graffiti. So
Floor is a special unit.
This is a little
Tony,
video about the project.
as you know, is Temp 1 is there because he suffers from Lou Gehrig's disease. He's in an advanced stage of Lou Gehrig's disease, otherwise referred to as ALS. He is not able to move his limbs or eat or talk or move any part of his body. But however, his brain is wide awake and he's just full of ideas and full of creativity. And so it's fortunate that you guys have entered into his life at this point in time.
And what we tried to do is just understand as much as we could about eye tracking. So using a camera, what kind of data can we get about the eye movement and how can we follow where the eye is? Then also reverse engineer his system and get software working on his system so we can understand commercial eye tracking systems. And then the general idea was to try to build a kind of DIY kit. So publish instructions and source code for anybody that wants to make an eye tracking system. And we developed this thing called the iWriter. It's basically like open source, open hardware eye tracking system. So instead of paying $5,000 or $10,000, or if you don't have $5,000 or $10,000, this is some cheaper system. Another thing about this project is we really focused on Tempt, like his style, his love of letter forms, and trying to design software specifically for him to. Usually when you think about software, you think about something like a Photoshop or Illustrator, creating software for millions of people. But this is creating software for one person, specifically for Tempt, and thinking about his approach. This is him using our system. And in order to draw, it's a bit like Illustrator. So if you stare at the screen, if you look long enough, it's like clicking the mouse. And from those points, you can make lines. From those lines, you can make letters. And from the letters, you can make words. And so this is kind of what it looks like. Once we had a system where he could draw, so this is the early days of just kind of getting software to work. Once we had that kind of system, we were thinking, what is the next step? And the next step was to actually go outside and project his drawings. So we don't have permission from anybody. If the police come, we have to leave really quickly. But what we did is we tried to find spots around LA, like buildings that had really dark wall, sort of like light surfaces with that pretty dark that could take projection, and then project his drawings, and then stream those drawings back into the hospital room, so that he's in the hospital room and his drawings are, projected on the side of the building and then streamed back in the hospital for him to see. So here we are. We have, I think, a gas generator here. No permission from anybody.
Corner, fearing for my life. No, up there in the tall building, unbelievable. Someone was tagging Temp's name up there. That was actually Tony drawing in his hospital room, and miles away, it was being projected onto the wall of this building.
And what was really beautiful is that every time we did these kind of projections, where he would draw and we'd go out in the street and project his drawings and stream it back into the hospital room, it became like a kind of party. So all of his friends and family would come out and chat with him. And it just was really beautiful to kind of have this moment of making drawings and then trying to get them out into the street and out into the world again. He said, that's the first time I've drawn anything since 2003. It feels like taking a breath after being held underwater for 5 minutes. And we built this software for him, and then he got better and better at it. So he was doing things with the software, that are really complex and quite elaborate. And whenever he would make a drawing, the data would get saved. So we were taking his drawings and exhibiting them wherever we could. This is our dream. If you know somebody who has a lot of money, this is what we want to build. So this is a really quick test of taking the drawing data. So this is drawing from his eye movement and then trying to control a robot to make the drawing again. And I teach, so I taught at Parsons School of Design for a long time, so these are some of my students there. Now I help run the School for Poetic Computation. But my students and I hack on the iWriter, kind of push it, try to develop it further, work with local children who are paralyzed and try to find some solutions for them, and developed a kind of version 2 of this project. My favorite picture of this project, we were out in LA working on it, and this couple invited us to come, meet Tempt. And so we were staying at their house, and their son was hanging out with us when we were working on the iWriter, and he built his own version of the iWriter out of toys. So I just like this idea. He was like with his homemade eye writer, but just to suggest the power of art, which is to inspire the next generation, but also that there are things in the world that governments are not going to solve and companies are not going to solve, but artists and people working together can try to solve. I'm going to show some other smaller drawing projects. This is, I really love 3D drawing, so kind of making drawings and adding a bit of dimensionality to them. So, that's something that the computer can do. If you draw on a piece of paper, it's quite flat, it's two-dimensional. You can make it 3D using perspective, but I like the idea of drawing and having a drawing that you could rotate and revolve almost like a wire sculpture. So this is an Android app where you can make a drawing, and when you rotate the phone, the drawing rotates. So it's just using the accelerometer and the gyroscope. And the idea is that it's a flat surface, so you're making a two-dimensional drawing, but then as you rotate the phone, the drawing rotates in 3D. And what I love about these kind of projects is you make creative tools and people use them in really interesting ways. So, we put this out there and, people started doing stuff like this or very childish things like just drawing faces. And then you get a lot of this, which I really like. I always forget to remove this slide when I talk to kids. But stuff like this woman in Korea drew a bird that I don't even know how she did this, and there's something really beautiful about sort of making creative tools and seeing what people do with them. I'm going to show another drawing project. This is a project that I did with Google, and Google has this satellite photographs from around the world, right? If you go to Google Maps or Google Earth, type in an address and it has, the whole, they have a really deep catalog of satellite photographs. And they were looking for alternative ways of exploring them. And the way this project works is that these are sort of alternative interfaces for navigating or exploring the satellite photograph. So with this project, you make a drawing, and when you draw a curve, it finds that curve in some satellite photograph. Or if you draw a straight line or a rectangle or a letter of the alphabet, it'll find something that is kind of similar to that in a satellite photograph. And I really like projects like this that involve a lot. There's a front end, right, of kind of a visual component, and then also there's a lot of data science involved in a project like this. So a lot of the work that I do when I'm working on making artwork, a lot of it looks like this, just sort of thinking about the data, collecting it, trying to clean it, and say okay, if I draw the letter Z, what are the closest things in the data set that look like a Z? There's a lot of non-pretty parts of the project. And then the second part of this project is finding dominant lines. So if you have a photograph, like a satellite photograph, finding coastline or a river or a highway and connecting them. So as you scroll, you're kind of just taking these satellite photographs and pasting them on top of each other to make a kind of infinite line. So no matter where you drag, you kind of just put the images together. So I'm really into this kind of work, which is a sort of data visualization, but not necessarily just in a sort of a more playful way. But the interesting things is that these are real places. So you can click any of these links, you can actually click on and learn more about the location. Now, I'm quite interested in artwork that involves the world, and this is a project. It's not necessarily a drawing project, but I think since I show landlines, it's kind of interesting to talk about this, and then I'll talk a little bit about open frameworks, and I'll show some examples. This project is really about radio. I love I think there's something really beautiful about radio generally, and just sound. And in New York, so I live in New York, if you get into a taxi, always the taxi drivers are playing really interesting music. And sometimes the music is like, you know, Senegalese or some, you know, it's almost like you're eavesdropping on a culture. If you kind of scan the radio dial, you can hear different languages and different sounds. And different cultures. And there's something I find quite beautiful about that. And then, who in here remembers this? Yeah, you all look really young, so you probably don't know that. When I show this to older people, they know what I'm talking about. So this is like early days of the internet. This is really beautiful. Like, we take streaming for granted now, but in the early days of the internet, this was like the streaming that you had was radio, and you could type in a URL and listen to radio from around the world. And there's something I find quite beautiful. Like, we take it for granted now. We have things like Twitch and all of these like live streams kind of everywhere, you know, video and all kinds of content. But for me, this is really amazing that you could listen to, just like by putting in a URL, you could listen to some other part of the world. And for me, that I find really magical. So I did this project where I tried to like listen to these radio streams from around the world and find things that sound like musical notes. And so a lot of times when I do a kind of project like this, I have to do a lot of research and reading and just trying to understand kind of like, how does pitch work, and how does how does radio work, and how do all these pieces kind of fit together? Things like MP3, like what is the story of MP3 as a format, and how can we take it apart? And then I did a lot of data scraping. So there's no like real great source for radio stations. So I did a lot of reverse engineering and hacking and tried to scrape as many URLs as I could. And then I just I built software that listened to the radio and kind of like tries to find things that sound like musical notes. What was beautiful is that I heard lots of really, like this project, I got to listen to a lot of interesting sound. And then I just wrote like one openFrameworks app that listens to one radio station, and then I ran 100 versions of them. So this is what my dock on my computer looked like. And then I just want to show you a little bit of what these musical notes sounded like. The amazing thing is that you don't need a lot of context to understand. If you hear a sound, you don't need a lot of context to understand where the sound comes from. So I'm going to play you just a really short clip. Right? You don't need to hear the whole song to understand maybe what culture that sound comes from. That a very tiny piece of audio actually has a lot of information. This is what the instrument sounds like. It's really cacophonous. So it's a keyboard, and when you press a note on the keyboard, it finds that musical note from somewhere in the world. And then these are actual like places around the world where these sounds are coming from. Yeah. And so the other thing is, when I was working on this project was around the time of the World Cup. So every once in a while I would hear a musical note that sounded like this. And the way this installation was set up is that there was a keyboard, and then there were 12 speakers around the keyboard. And the general idea is that depending on where the installation was set up, we set it up in London first. Those 12 speakers, the sound would come from where in the world the sound was coming from. So if it was coming from Asia, it might be coming, on the right side, from Africa behind you. That those speakers represent the orientation of where the sound from the world was coming from. The studio always looks like this. We always have just hacking, taking pieces apart, breaking things, buying lots of equipment, trying to figure out how to construct this kind of thing. And then this is what the installation looked like. So we built an instrument and then had this kind of like a little bit of a display so you could see where the sound was coming from, and then also the speakers. And on the speakers, it would show you or say the name of the city or the country where the sound is coming from.
The idea is that there's sound all around the world.
This is me saying exactly what I just said to you. So fast forward through that. But these kids are really cute. They get very excited. So if you do like...
Oh, good.
Yeah.
Okay.
I was trying to teach this woman how to play octaves, but... And then you could also, with the knob, sort of like go through and say where in the world you wanted the sound to come from. So it sounded really crazy and kind of cacophonous, but I think there's something very beautiful about kind of understanding that there's all this data in the world, whether it's satellite photographs or sound or all of these kinds of interesting pieces of information. And as artists, we could be collecting them and rearranging them and creating new meaning out of them. So I just wanted to show that project. And then quickly, I will talk about Open Frameworks just to explain sort of the tools. I'll show some examples, and then I'll kind of introduce OF and talk about how I use it. The main thing to say about Open Frameworks is that it's this kind of open source framework for creative coding in C++. It's not dissimilar to processing. So if you were in the previous workshop and you saw Casey talking about processing, it kind of comes from the same family tree. We think about Open Frameworks as this like kind of toolkit for artists. C++ for non-nerds, C++ for artists. It's use-driven. It's like designed to make things easy. I want to show some projects, so kind of hype it up a little bit, and then I'll show you. Show you what it looks like. This is one of my favorite projects that was made with Open Frameworks. It's called Laser Tag, and this project is combining a camera, really like bright projectors, software that was written in Open Frameworks, and then this like really illegal laser. And don't tell anybody. And the general idea is that you could, from the camera, you could track the green dots. So as you take the laser, you point it at the building, and then the camera is looking at the green dot, understanding where it is, and then allowing you to draw graffiti on the side of a building.
Okay, go ahead. The laser is what you have.
So I'll get here.
Them a come with them chopper, yes. But I know that's no proper. Them a come with them 45. But I say we got to survive. Them coming on the scene, but they've got to be clean. Don't bring your M16. I mean we drop in me laser beam. So pass me the laser beam. I make me wipe out the wicked them clean.
And then one of the things that I find really beautiful is like every day kind of go to Vimeo, YouTube, Instagram, and kind of look at the hashtag and see all of these interesting things that people are making. I want to show this project. I think the video. Let me go to the mica deck. This is probably my favorite Open Frameworks project. This is a project by Chris Segru. So Chris is the artist that I mentioned. She worked on the iWriter. And she made this project, which I find really beautiful. It's probably like my favorite Open Frameworks project. This is called Delicate Boundaries. And the idea here is that there's a computer screen. And on the screen, there are these bugs that are moving. And when you put your hand up to the computer screen, the bugs actually come off the screen onto your hand. So it's tracking where your hand is. And then the elements actually leave the screen and go onto your hand. And we always talk about artwork leaving the screen, like wanting to get away from the computer screen and into space and into the environment. And this is a really amazing metaphor to describe that process. So I can kind of show you what this looks like. So it's just very simple. You stick your hand next to the screen, and then the elements come off the screen onto your hand. yeah, I don't know. I just think it's like there's like no better way to describe what it means to actually leave the screen, to make artwork that leaves the screen. And then we do workshops, some silly stuff, like this is a project by Lala Lab that switches your face with somebody else's face. This is a project by Chris Segru. It's called Out of Bounds. So using an infrared torch allows you to sort of see through the wall into a kind of out of bounds area. For many years, I've been, IBM Video Play. For many years, I've been doing at IBM, sort of Art Science Research Center, working with OpenFrameworks. And this is one of my favorite projects that we did at IBM that Friedrich did, Friedrich Kirchner. And so this is a really crazy project. The general idea is that you have this kind of pool. Oh, sorry. I'm like really bad at controlling this video. You have this pool of black liquid, and you wear a white bathing suit. And so you can see there's like a kind of like a big pool, and then on the screen there you see the kind of video image of just what it looks like to be kind of, if you're wearing white, if you get kind of dipped in this black liquid. And
milk scanning and ink scanning.
And the general idea is that if you drop somebody or drop an object into this liquid, you can make a bunch of photographs of them. And then from those photographs, you could actually build a 3D model. So this is a really like primitive kind of 3D scanner that you take a human body and you drop it into liquid. And if you take a bunch of photographs, you can make a kind of 3D model. So this is very similar to like what Kyle was showing yesterday, but in some way, kind of primitive 3D scanning technique. This is an augmented reality record. This is a project I really love. This is called Big Screens. There's this giant like screens in New York. So not dissimilar. Like yesterday, we were putting content on this LED screen. So it's not dissimilar. This kind of giant screen. The way this project worked is that you call in with your phone, and you get a character based on your phone number. And if you scream louder, your character gets bigger. So it's this kind of thing that invites people to like just start screaming. And then this is a project I really love by one of my former students, Zach Gage, who's an amazing game designer. He made this game called Lose Lose, and the idea is that the characters in this video game are based on files on your hard drive, and when you kill the character, it deletes that file on your hard drive. And then when you die, it deletes the game itself. So no matter what, you lose. And the crazy thing is that like this game like really deletes randomly files on your hard drive. And you would think that nobody would play this game, but actually thousands of people have played it. And then at some point, Semantic labeled this game like a virus or like a Trojan, because it does bad stuff. And so if you go to his website, there's like times when you go to his website and then like Chrome will like go bright red and be like, don't go here, because he made this game, which is really destroying. And then it works on mobile devices. We do a lot of stuff with. Theo made this thing which I really love, which is like using his phone like a record. And people say, why are you invested in open source? And a few things like I will say, I'll make a few arguments, then I'll show some things. Art, most people, when you tell people that you're doing art, they think of this sort of kind of solitary genius, misunderstood, working alone in an attic. And I really think like art is more like a laboratory, that artists are kind of a research and development department for the future. Like I don't know. In English, we say research and development, that companies have like R&D departments that are imagining what the future would look like, and artists are kind of R&D department for humanity. There's a big thing like DIY culture, like do it yourself, and we're really interested in DIWO, do it with others. That's the kind of main ethos of the, I guess, like, processing, open frameworks, all these sort of toolkits. We've done a lot of workshops, events, things where we come together, hack, build stuff. And then I think if you have a group, you have to have a gang sign. So we have, Open Frameworks has a gang sign. Everybody gets it except for this. She had trouble. And we do all kinds of stuff like make we made a laboratory at Ars Electronica, hang out, work on projects, and just try to like share and make interesting stuff. I'll show you that. This is fun. This is Super Mario Brothers that you play with your body. So So, and then quickly to say, open frameworks. I'll do like maybe a few examples. Open frameworks is a tool. So processing, I think like processing is Casey was talking about it earlier, and it's really like an amazing tool for learning. And so if you're just getting started, I always recommend students to take a look at that. Also, P5JS are just like really, really friendly, lots of resources and lots of materials. And Open Frameworks is not necessarily a learning tool, but it's great as a making tool. And there's a really large community of people making and sharing and kind of working with it. And so I'm gonna just like kind of open up a project and just start coding. I'm not gonna go into too much detail about all this kind of technical stuff. But if you're curious, like I would say for any of these tools, just go to the forum, say hello, ask a question, and like the community is really, really friendly, and there's lots of people, who I think Open Frameworks has been really lucky processing P5JS, other tools out there have been really lucky and attracting very friendly, warm, nice people. So the main thing is that it's like impossible to learn this stuff alone, that you actually need community and you need to be talking in order to learn. I'm gonna just create a super simple sketch. And I like to show this just to show a little bit of kind of process. So I'm gonna make code a little bit bigger so you can read it. So let's try Grandpa. Can you read that? Grandpa? Great Grandpa? Grandpa. Okay, let's do Grandpa. All right, so I'm not gonna do anything super complicated. I'm just gonna let's do a few things. Set circle resolution, 100. Let's compile and release. Let's make the window, 1,000 by 1,000, and then set the background to be black. And then draw a circle at 500, 500 with the radius of 100. Write this the new way. Okay. So I'm going to start quite simply just by making a window and drawing a circle. So very simple, like, just say, like, set the background to be black. You want the window to be this size. And then what I like to do, and I usually just show this to students so they can kind of see is an interesting place to start is like the computer's really good at doing a lot of something. So if you tell it, instead of drawing one circle, I want you to draw 1,000 circles. And so this is a for loop where you tell the computer, like the power of code is that you're reading the code from top to bottom. It's just text, and when it sees an instruction, it does it. And the power of code is that you can tell it to do something many times. So you can take this playhead, which is kind of moving through your text, but actually say, let me repeat that. Let me kind of do something multiple times. So now I'm going to draw 1,000 circles, and they're going to be spaced on top of each other. They're just like I'm just using the count as the y position. So we're going to have a circle which is centered at 0, and then our y position of 0, and then 1, 2, 3, 4, 5. They're all on top of each other. But this is like, now it looks like a line, right? It looks like some kind of graphical thing. Make this a little thinner. And then I really like to play with math. And so one of the things that I like to do is start to introduce time and use sine of time. So sine, not to get super mathy or math professor, but like if you take the sine of a number, you get like a number that goes between -1 and 1. And so I'm going to get the time, I'm going to take the sine of that, and I'm going to use it just to move and start to animate quickly. So we'll say float time, we'll get elapsed time. And then I'm just going to say, I'm going to move back and forth. We'll say 200 times the sine of time. And so now all these circles are going to go back and forth. They will be centered at 500, but now they're going back and forth, right? They're just starting to animate, maybe every 6.28 seconds going back and forth. But we can like offset that a little bit. So let's try adding a little bit of like a kind of offset based on the count. So now we get something where we're going, instead of all of them going back and forth at the same rate, they're now going back, they're offset a bit. And then we can try stuff like, let's also do the same thing, but let's do it with the radius of the circle. So we'll say something like, 50 plus 40 times the sine of time. That means they're all going to get big and small at the same time. So, this is changing the radius, and now the radius is going like between 10 and 90, right? It's kind of animating back and forth. We can space that out a little bit. So I'm just going to make this a little different. Right, and so now we're drawing a bunch of circles, and we have them like getting smaller, thinner, and larger. That looks a little weird. I'm going to make that more kind of. And then the next thing that I always like to play with, and maybe let's make this a little bit different in terms of time. Next thing I like to try is color. So I'm just going to, so now I'm starting to get a form, right? We started with a circle, then we made 1,000 of them, then we start to move them, then we start to kind of offset that. Now we're starting to get a form, which is kind of cool. And I'm just going to add color. So I'm going to say offset color. 127 plus 127 is the sine of time. So I'll hook it up to time just so you can see, that's animating, and they're all going to change color in the same way. So they're going to go like from white and then back to black. So you get the idea. But here, let's just take like I. We'll do, I times 0.2. And then we'll wind up with a bit of a gradient, right? So some of the, the circles are going from white to black and then back to white. And one of the things that I love about code, just as a medium, is that as you start to change these numbers, you get really kind of big impacts in what the visual form looks like. So here, this is saying like times 0.2, but if I make this 0.1, it's going to be more gradual, the gradient across these circles. And then one of the things that I really love to do is then play a little bit with red, green, and blue and make them slightly different. So this is one of my tricks. And just gonna like change a little bit the scale factor for red and for green and for blue. So it's just slightly different. And you start to get this glow, right? Because red, green, and blue are now moving at different rates. So only reason I want to show you this is just to see how you can sort of start from something quite simple, which is a circle, and then you add a for loop, and you start to like control the parameters with time, use a sine wave, and you start to get, I think, some sort of interesting, result. That's a sine and cosine. I'm going to show a few more examples. One of the things that is really kind of interesting about OF is that you have access. It's like very good for doing computer vision and getting data from a camera. And I think that's one of the reasons why OF became kind of popular. So I'm going to just open up the video grabber. And grabber.setup, 640 by 480, grabber.update, grabber.draw. So this is just going to get data from the webcam and draw it on the screen. So we can run this. Let's put this in release. Okay, so here I am. Hi, but you can get data from the camera. You can draw it, but you can also say like, what is the value of the pixel? Like, how bright is the pixel? And then use that in a kind of interesting way. So, let's set the background color, OF background. I set the background color to be black. And I'm just going to write a for loop where I go through the pixels of the grabber. So say for int I equals 0, I less than 640, I plus plus. And I'm not going to do every pixel. So instead of, usually you would count by 1, I'm going to count by 10. So I'm going to jump every 10 pixels. And then this should be J less than 480, J plus equals 10. And I'm going to ask for the color. So this syntax like a little bit more complicated, but trust me. Get color, IJ, and float brightness equals color.get brightness. And that's going to give us for every, we're going to go through every 10th pixel and just say, how bright are you? Like, are you dark or light? And then I'm going to use that in a very simple way, and then I'll make it a little bit more complicated. So I say float brightness, and then I'm just going to draw a circle. OF draw circle at IJ, and I'm going to scale it based on the brightness. So we'll say float radius equals OF map, brightness, from 0 to 255 to be between 0 and 5. So if the brightness of the pixel is 0, we'll have a radius of 0. If it's full brightness, we'll have a radius of 5. So this is going through, grabbing the data from the camera and then saying like, how bright is the pixel, and using that to scale a circle. So you can see, and one of the things that I'm really fascinated, this is quite straightforward, but one of the things that I'm really fascinated with is like, how subtle do the differences have to be? How subtle can you be in order to see an image, right? Right now it's pretty easy to see an image. But if I did, for example, instead of 0 to 5, if I said between 3 and 4, can you perceive it? And sometimes it's a little bit tricky because sometimes it looks different on my laptop than on the screen, but can you see me? Yeah? Okay, so let's try like 3.3. I think that's kind of interesting territory, which is like, can you see? If I'm moving, can you see? Yeah. And then I'm going to do something really silly, but I find really powerful. So I'm going to draw a line. I'm going to rotate. So this, again, requires a little bit more code than normal. OF translate, IJ, OF rotate based on the brightness, OF rotate Z, let's say float angle equals OF map, brightness from 0 to 255 between 0 and pi, let's say, yeah, pi. And then of rotate Z, angle times, let's do 0, sorry, 180. I need it in degrees. OF line from 0 minus 5, 0 to 0 plus 5, 0. This is going to just draw a line, and the line is going to rotate based on the brightness of the pixel. So I'm also really fascinated with this, which is like, how can you represent data? So usually you would do stuff like kind of, use scale a circle to represent a brightness of a value. That's really straightforward. But there's also there's less straightforward ways of taking the data and translating it and transforming it into something kind of meaningful. I'm going to show one more example, and then happy to open it up for questions. And I just want to show this. How many of you were in the workshop with Casey previously? Okay, so I just want to show this actually. This is like, I'm not going to code this right now, but this is like very simple example of like kind of how rule sets work with code. And I think Casey also showed this in the end of his talk. But this is a code where we've created a line object, which is basically 2 points, point A and point B. And we have a collection of them. This is like a growable array. And what we're going to do every frame is pick a random point and pick a length of the line and pick an angle for the line. And so we could say, let's do OF random between -1 and 1. And then we're going to add the line to the array. And I'll do that right now. So we'll just say, I'll get rid of this code here. This is just going to say pick a point in space, make a line based on a certain angle, and add it to an array every frame. So this is really straightforward. Like just pick a line that's always the same length, 100 pixels, and just keep adding it to the array. But we can also ask a question, and we can say, are you intersecting with any other line? And if you are, don't add it to the array. And so the first one, obviously we have to do the first one we have to add to the array because we can't check. Like the first one, there's no previous lines to check with. But then we can actually check and say, do you intersect? And if you don't intersect, then add it to the array. So you can start to ask questions, and the computer is quite good about allowing you to ask sort of logical questions where you say like, my fault. Where you can say like, okay, only add to the array if you don't intersect. And now you start to see a very different drawing occur. And I'm going to speed it up so you can see. So instead of doing 1 per frame, I'm going to do 100. And so this is picking a random angle between like 1 and -1. But you could also say like pick a random, it could, the angle could be, you could say OF random 1 greater than 0.5, and then pick either like pi divided by 2 or 0. So this is going to be 90 degrees, like pick, either draw horizontal lines or vertical lines. And you start to see like patterns emerge because, because of this line here, you can't draw any horizontal lines, right? Because they would intersect with that line. And one thing that I find really beautiful about this art form is that you sort of set up a condition, but you don't know what is going to happen. Right? You're sort of asking the computer to solve these problems. And part of the joy or part of the magic of it is actually just kind of formulating those questions and then writing software to sort of see what the results may be. So I'm happy to answer. So, yeah. Yeah. I don't know a good answer to that. I think it's part of it is like sort of developing intuitions and shortcuts. And so I think that involves like knowing I mean, it's helpful to know the basics, and I think as a beginner, it's really useful to learn, how to draw and how to load things and how to kind of respond and play with things in a creative way. But I think part of the practice of becoming expressive with this as a medium is about developing intuitions and saying, like, for example, like, I also maybe not intuitions, but also like sort of shortcuts or things that help you do things fast. So for example, taking the sign of time, which I just showed you that example with the circles. I do that probably every day. I take like elapsed time, I take the sign of it, I use that in some way, just because that's a really quick way to animate, and it's just a shortcut. And then part of it is developing those shortcuts or those patterns that you can then use. And I think the majority of the work is not necessarily in the code, but actually in the changes. So like here, for example, like I set this up and then I changed one line of code and it looks very different. And a lot of what I do as an artist, I think, is tweak and adjust numbers and not necessarily like write lines of code, but actually spend time just like changing something from 0.01 to 0.02 and seeing what happens. Yeah. Sure. Yes. Did you consider using a drone? We haven't, because when we did this project, it was like not probably prohibitively expensive to do stuff with drones. There are really interesting examples now with drones. So there's a graffiti writer who's a friend of ours named Katsu, who's been doing really amazing stuff with drones and graffiti. So I think it's totally possible to do now versus when we were working on this project. Yes, yeah, for sure. Yeah, I think it's, yeah, totally. Yeah, good suggestion, yeah. Oh, sorry.
Yeah, one more. Did you ever play a real musical piece with the piano setup that you created?
I'm actually not a musician. I can play chords and kind of like mess around on the piano, but there were some musicians who came to the exhibit and they really loved it because it just sounded crazy and kind of cacophonous. So, yeah.
Match the original piece?
No, it sounded like just chaos. Yeah, it did not sound like music, but it sounded awesome. Yeah.
My question is about limitations and creativity.
Sure.
Did you think that your technical or financial limitations feeds your creativity? My question is.
Yeah, I think that's a really interesting question. I think constraints definitely help with creativity, and so one of the things that I find as a teacher, like if you ask students, if you just say like do something in this space, oftentimes you get worse results than if you give them rules, right? If you say like the rule is like, no external content and needs to be this length, or needs, you add constraints, as actually creativity comes from solving how to make something within a kind of boundary and actually having no constraints, if you have sort of unlimited budget or unlimited, technical experience, is actually maybe that could be inhibiting in some way. So I think constraints are really helpful. I'm not sure if I have a good answer for myself, but I think a lot of the work that I do is also informed with a sort of DIY aesthetic and doing it, not necessarily using fancy equipment or really sort of impossible things, but trying to say like, okay, if we have a webcam, what can we do with it? Or we have, this kind of cheap pieces of material, how can we make something interesting? Any other questions? Yeah.
Maybe one. Yesterday I realized there is an issue on GitHub about launching multiple projects and actually support for Xcode 10.
Oh my God. Okay, we can talk afterwards. I
Yeah.
might need a beer.
Yeah, okay.
So yeah, there's lots of one of the problems that we have, it's free and open source software, and so we move at a very slow pace. I feel a lot of times when you have these projects that are basically all contributor driven, right? Nobody's getting paid to make open frameworks. It's very much driven by community, and it matters who has time when. And sometimes, oftentimes our software exists in ecosystems where you have companies like Apple, which are really aggressive and breaking, and changing things and pushing changes. So in particular, I know the problem. We can talk about it later. Yeah. Other questions? Yeah. Well, I'm really delighted to be here. Please I'll stick around for a bit. Please catch me if you have anything else that you want to talk about. And then just to say, I do open office hours. So if there's anything that I said today or in the talk yesterday or anything you have kind of a doubt about or a project that you're working on, I announce it on Twitter. And I'm really happy to talk to you then. I spend about 20 minutes talking to people. I do 2 to 3 hours a week. And so I'm happy to meet you here, or meet you in open office hours. If you're in New York, please come visit the School of Poetic Computation. We also have a call for students for the springtime. So if you want to come to New York and study this stuff, it's not like, it's a 10-week program, so it's quite different than a master's program or some other kind of education experience. It's really kind of special. And then the other thing to say about this open source tools is they're full of really friendly people. And if you're not part of any of these communities, we really welcome you. We're really excited, and we want your voice. We want you to feel like there's a seat at the table for you. So, please come join us. Thank you.